looked at it. I looked at the views of Brno. I like this city a lot. So thank you again. And now let's get to the main part of our meetup. Petr Joachim. So using Python in production. Awesome.
It would be a different topic. But who cares, right?
Yeah, surprises. We like that.
Yeah, I like surprises either. So can I sit here?
Yeah.
Because I would be walking around all the time. So I'm going to talk about databases in ev.com because, as was already mentioned, we do search of flights differently than others. I'm a senior developer in search team, so yeah, I could get to the proper detail of that. So yeah, we are searching for flights, and also we are somehow selling flight tickets. And to do that properly, we need to own all the data. That means that our database of flights is quite huge. I will talk about it later. And we need the data to be able to compute all the combinations because yeah, there is a huge amount of them. Yeah, and today I will talk about how we did this part of our job later and how we are going to do it now. At the first, I would like to talk about flights data itself. The problem number one is that the data is changing like constantly because flights have prices and they have some availability and free seats on board. So right now we are processing about 40,000 flights updates per second. So it's like 3.5 billion in each day, and our database is only 1.2 billion of flights. So we are constantly updating all the data, and it's when you have done something with databases, that kind of updates is quite painful. So yeah, we have to switch our solution for something new. Again, this I will talk about later. The data of flights, if we don't see a flight for 2 days, we assume that the flight is not available and we can't sell it anymore, so we couldn't offer it in our search results, and we have to somehow invalidate or delete the data, and that's why we are constantly updating all the flights and we are looking if they are available, and yeah, that's it. Our database today is about 2 terabytes of data. The problem number 2 is that the flights data itself is quite complicated because you have all the combinations of flights like one-way and return flight, and you have so many prices in them because yeah, air companies are offering like infant prices and then some discounts when there are more passengers than one. So it's somehow hard to store that in some good way. And the most painful problem with data of flights is that there is no global identifier of flight. So if you have return flight from Moscow to London, it's return flight from Moscow to London, and you have to deal with it. The only thing you can do is to rely on segments of the flight, and yeah, that segments also don't have any identifier in itself. So you can use like number and source report and destination report and this kind of stuff, and then take all the segments together and hash it and get some identifier of one flight. Yeah, that's with the flights. And yeah, as was already mentioned, we are a startup company, so we used to do things like in a hacky way. So at first we hacked some solution which was kind of MVP, and it was working somehow, but yeah, it was using a single Postgres server with all data in it, but back those days, like 2 years ago, it wasn't billions, but millions of data, so the problem was such small that all database somehow fits in one server only, and it worked. So for that database, we had a consumer which was constantly updating the data, and it worked. Yeah, just fine. Later on, the data couldn't get to one server, so we had to put another server in place. So some engineer decided to make application sharding, and yeah, it worked again. So back then they implemented some kind of router which was holding all the information of where flights should be stored, and then we had a problem with Postgres itself because the writes was so slow that we need something more fast. And back then the engineers wrote some caching layer in Redis, and they developed a complex mechanism to invalidate and fetch data from Redis to know what was updated in the data from our data acquisition team, and then updated only the data in Postgres which was updated. Yeah, and it's complicated only when I said that, so you don't want to read that code. So right now we have more than 50 servers running that solution, and it's somehow sufficient, but it's so fragile that nobody wants to touch that code, and nobody wants to have an outage of that, because every outage of any server from that cluster causes us some data loss, because there is no backup plans, no redundancy, and yeah, it's not okay. So we have decided to implement some best solution for that. We call it current solution. And the objective is to make our architecture simpler, because we want to throw away that router thing and that caching in Redis. So we went to rewriting the database itself, and whole company relies on the data. So we needed to make it in some way which is sustainable and won't cause any damage to the production. So we've prepared some mirror of the data, and we have prepared a queue which holds all the data, and we can read it and don't affect the production. And then we can build another solution or test another solutions on it. Yeah, and we have tried many solutions of queues. We have tried Kafka, which Andre will be talking about if he managed to get here. And we have tried another implementations of queue, and it was all useless because we want to solve the database. So we get back to Redis queues, and used on the databases. So we have used some crazy Postgres sharding tool, which was not able to handle all the data changes because it was somehow limited on 10,000 writes per second. It was not enough. So we ended up in big databases, and we jump into running Cassandra, and we are in the phase that we are big enough to use that kind of databases, and Cassandra somehow implemented all features we knew we want from a database. So we went to Cassandra, and it has some dark sides, like it's written in Java, and we don't know any Java in our company. So it's quite painful to set up the whole cluster of Cassandra with no knowledge of Cassandra and of Java. So we went through all the documentation, and it was so painful because there are no classical transactions like you are used to when running ordinary SQL servers. It handles some kind of transactions, but not that transactions. And it has some crazy things with primary indexes. If you want to go to the detail, let's just come to me with a beer and we can discuss it. Because it's so crazy. You can specify one primary index, and then the documentation says that, they are some secondary indexes, but don't use them, they are too slow. So when you end up with querying the tables, you need to know what you are querying, and if you have table of users, which consists of user ID and name, and then you need to find a user by the name of the user. You can just do that in Cassandra. So the good things of Cassandra, the things which were there, the good things of Cassandra is that it has nearly linear scalability. So if you add 2 times the server, you get 2 times performance, which is what we need because we expect our data to grow constantly, and we don't know to burn all the servers. So right now we have a cluster of 25 servers, and it handles about 300,000 writes per second. And it's quite good. It's sufficient for our use. So at the end, it's fast enough, and we don't need the layer. It's a cluster, so we don't need the router, and we ended up with only single Python consumer, which is 500 lines of code, and it does all the data storage, which is quite good because we save a lot of thousands of lines of code. So I would like to say some stories. At the first place, we have read about Cassandra, and we know that there are some implementation in C++, which we thought it would be better, but we ended up in the state that the technology is not so mature. So we just skipped that because it was not working. Even though it was promising 10 times better performance, and they had some benchmarks which we believed in, but it was not working. So we get back to Cassandra, and then we had some consultants for Cassandra. They was from Serbia, and the first thing they like advised us was to rewrite all the stuff to Java, which is insane, right? Because we like Python. They actually advised a lot of good stuff to us, so it was worth it. But we had that small problem that we were not able to like balance the cluster, because all the time our monitoring tool was saying that hey, one node has load 100 and all the others have like 10. And yeah, we ended up with small bug in the production that says you can connect to JMX server, and Cassandra was not able to somehow compute the load of the servers, so it didn't balance. So after half of a year of this bug, we are now in production, and yeah, and that's how we done it. So that's it. Any questions?
Thank you. Thank you. Yeah. Yeah, you can ask questions in Russian if you'd like, if it's easy for you, and we have awesome translator Grigory. Okay?
Thank you so much. One question. Did you compare Mongo and Cassandra? What's about performance of Mongo?
Like Mongo and Cassandra? Yeah, we have read about Mongo that it doesn't scale that well, so we don't even try it.
Коллеги, кто не уверен в своем английском, вы можете спрашивать по-русски, я традиционно переведу. Next question, please.
You said that your KiwiCom is unique program, yeah? But what about Google Slides? There is a lot of programs like that. What is the difference?
Actually, Google Flights are using kiwi.com for ticketing flights.
If you want to talk like about online travel market, it's a bit different subject. It's not technical question.
By the way, we are different from other companies is that we have all the data in our database, so we can make these combinations, because other companies like Skyscanner it was mentioned, they are meta searches, so they search through several APIs and then only somehow sort the results. And yeah, they have the data somehow, but they are not able to combine all flights together because they will be slow at that. And we can, when we have the data, we can pre-compute all the combinations in our search engine, and then we can operate. Okay. And we also are a meta search for many other partners, like Skyscanner is buying results from kiwi.com, so you can see our results on other pages as well.
More questions, please. Okay.
Thank you very much for your presentation. I would like to know, given your scale of databases, given this huge size, how much memory do you require for the Redis layer, for the caching layer? How much is enough?
Okay. Actually, I don't know what scale of memory we have for the Redis layer. But for the Cassandra servers, they have like 250 gigabytes per each node. So in combined, it's a few terabytes of RAM memory. Yeah, it's quite a lot, but we need it. And for the Redis layer, I think it would be around that 2 or 3 terabytes of RAM for that caching layer, because it needs to store all the data in the memory.
Okay, I think 2 more questions, yes?
Yeah,
Okay, 2 more questions, and we will jump for next speaker. Русский, английский.
Thank you for your information. You have told that you are using in Cassandra only primary indexes. So do you use any extra databases, fast databases, to help you operate with your indexes, like Metastore, like Postgres, for example?
No, we are aiming to use only Cassandra for that thing. We have a small Redis which we are using for counter, so we can somehow specify IDs for the flight or make IDs for the flight, because if we do hashes of all the data which identifies each flight, it's like 40 bytes per ID. So in order to shrink that size down, we have some mechanism to make IDs for flights smaller and to make them unique. That's the only one.
Perfect. And the last question, okay, here it is. You can actually catch our speaker after his speech and ask him all the questions you want alongside the beer.
But please only in English, because I don't speak Russian well.
This flights information looks like a huge graph. Why do you use relational database instead of graph database?
This kind of data I have described is only for storing the data, because we need to load details to search results page, and we are actually not searching about them. We have another storage for searching on that database, but it's not graph database either, because it's too slow for our usage. We have tons of pre-computed data in huge RAM storage, but it's kind of a different story.
All right, so thank you very much, Petr. Feel free to catch Petr on the beers when he